Sometimes sequences are defined by what we call a recursive formula, in which we have a way to compute the value of a term only when the value or values of preceding terms are known. When defining a sequence recursively, we give explicitly the value of the first term or the first few terms and then give an equation that we use repeatedly to find values of other terms. In the example, we have the sequence a sub n for which the first term is given and is equal 3. And then we have an equation that tells us how to compute the term a sub n. But as you can see, the value of a sub n depends on the value of a sub n minus 1. So to compute the value of, for example, a sub 2, which means that I'm using n equal 2, I will use the equation and will get 2a sub 2 minus 1 plus 5, which is 2a sub 1 plus 5. So to compute the value of a sub 2, I need the value of a sub 1, which we have. It is given. So this is 2 times 3 plus 5, and it's 11. Now if I continue and I compute the value of a sub 3, where n is equal 3, we'll have 2a sub 3 minus 1 plus 5, which is 2a sub 2 plus 5. So again, to compute the value of a sub 3, I have to have the value of a sub 2, which we have. We computed this. So it's 2 times 11 plus 5, 22 plus 5 is 27. So suppose I want to compute the value of a sub 10, that n is equal 10. According to the equation, to compute a sub 10, you'll have to take 2 and a sub 10 minus 1 plus 5, and this is 2a sub 9 plus 5. So you can see here that to compute the value of a sub 10, we need to know the value of a sub 9. And to have value of a sub 9, we need the value of a sub 8, and so on. So when a sequence is given by a recursive formula, we cannot find the value of an arbitrary term without finding values of all the preceding terms.